Captain's log, stardate 2013-09.24. I am well, I've been if I'm gonna tell you about life and the universe and all those things, at least I can be accurate, and I've been like looking up a lot of facts since last time, because I really wanted to be precise for you guys. So I have a couple of disclaimers for you. When you say something and it's not completely accurate, you do a disclaimer. You edit what you said or what you meant. And I wanted to put a star date on it. I looked up star date, and it's a term from Star Trek, and they always like start the show with the captain says captain's log started 41-167 something. And I was wondering, how do they calculate that? And it turns out they calculate it in many different ways. And according to the most commonly used log, the start date now should be something like 67-198.25. I just can't relate to that. And this whole thing is about you and me finding our place in this thing we call the universe, and I want something we can both relate to. So my star dates are gonna be 2013. That's the year of our Lord, Anno Domini, after Christ. 09 is the month, 24 is the day, so that's kind of the format I arrived at. And right now it's night again. It seems to be easier for me to release all this stuff when the day is past, I've always had some trouble finding rest, I guess we all have trouble finding rest. We all do weird rituals before we sleep. Some read, some have to do push-ups. I can recommend that, by the way, because you think you're gonna be all pumped up and stuff, but you're gonna be very you're gonna use a lot of energy you maybe didn't use during the day, and your body is gonna release serotonin and dopamine in your brain, and your sugar deposits are gonna be used up, and you're gonna find like a whole different kind of rest. Also, like working out late at night, or late in the evening, I can recommend that, because so many of us go to bed every day, and the mind is tired, but the body is not, because you've been sitting all day at the goddamn job, somewhere on a chair all day, and your body just wants to burn energy, right? Having sex, go boxing, rock climbing, whatever, but you're not doing that. And your mind is exhausted because you've been looking at passwords and shit all day, right? And completely irrelevant emails and documents, and your mind is just scrambled from all this bullshit. But your body is fit for fight, so you're laying there late at night and you're just thinking, how am I gonna fall asleep? And people do the craziest things. Do some push-ups. I can recommend that. But it's kind of late here, and it's all dark. I'm lying down. I guess there's kind of a difference in your voice when you're lying down. You breathe a different way. You're more relaxed. This is kind of like a sensory deprivation tank or something. It's you don't get a lot of input. Like I don't think I could be doing this in like a busy square or on the train or anything. It's very relaxing, just having the silence and the time to do this. So we're gonna touch on a lot of different topics today. I'm gonna I'm gonna take I'm gonna take a lot of the subjects we already touched and retouch them because they're so important. So I said something about disclaimers. I've been saying some numbers I really want to rectify here, and the first one is the distance to the moon. It's actually 384,000 kilometers to the moon. And you know the speed of light is 300,000 kilometers per second. So that's like 1 second to the moon for a flash of light. And when you're staring up at that big old moon, the light that hits your eyes has only been traveling for 1 second. You know, the light is not coming from the moon; it's being reflected off the sun, but it's only 1 second. So I was thinking, how are you gonna relate? You know, I'm talking about being on this spaceship we call planet Earth. And how are you gonna relate to the immense distances and the humongous numbers we're talking about? You know, there's something called an astronomical unit. Yeah, it's designated AU. It's like the distance of Earth's the distance Earth travels around the sun. But you know, the human brain, we need to see it. You have kind of like a feel for how long the distance is to the moon, because you can see it. You can see how big it is, and you know kind of how big the moon is in correlation to the Earth. So you kind of feel a relationship with that distance. Same with the distance to the sun. You can relate to that, right? So I was thinking, how you know, we talked about the edge of space, and where's that? You know, we were talking about this photon that's been traveling since the beginning of time, 13.7 billion years ago, and where is that photon right now? You know, I could give you a kilometer number. I actually calculated that. It's like 1.3 times 10 to the 23rd power kilometers away. I mean, that's the radius of the universe, is 1.3 times 10 to the 23rd power kilometers. And who can relate to something like that? Like, what is that? I kind of like this. It feels just like teaching, sharing. You know, I wanna try to explain a lot of stuff to you, so you can like taste it. You can feel it instead of just being some kind of weird numbers that's floating around. So you know, 10 to the 23rd power means 10 followed by 23 zeros. And what is that? Like, you never calculate with a number like that in your daily lives. So I was looking at a light year, right? How long? How far is a light year, right? And you know, 1 light year is 9,460.8 billion kilometers. 9,460.8 billion kilometers. And still, that number is also hard to grasp, you know. So we have these distances, light year and an edge of space. But we need to break it down into something we can something that makes sense to the human mind. So I was thinking about like how many trips to the moon is 1 light year. And that's actually 16 million return trips. And once we get down to 2 millions, then we start getting like to the common ground that we've been talking about, you know, because we can grasp the number million, right? We know that number is 1,000 times 1,000. Like some of you guys might even be millionaires, and you have that kind of money. But it's not a strange, like unfathomable number to us. So 1 light year is the time it takes a photon to travel to the moon and back 16 million times. Okay. And if you want to have that, do the same thing with the sun. It's 30,000 return trips to the sun. And that's a light year. So the big one, of course, is the edge of space, which is kind of becoming my favorite thing right now. Is I want us to be on the same stage, you know. I want you to know. You have to know where you are right now. how can you tell anybody or yourself where you wanna go if you don't know where you are? I think a lot of us have trouble, where am I going? Like, what do I want to do? And I think a lot of it comes from that you don't really know where you are. You're on this planet that's whirling around the sun, and the whole solar system is at the edge of the galaxy, spinning around, and the galaxy is flying away from the center of the universe. But how far is that? Where's the edge? And so I played around with the numbers, and I actually came up with the distance to Pluto. Pluto, that's that adorable brown dog, from the cartoons. Pluto. Fortunately, I can't do a very good Mickey Mouse, so you're gonna be spared from that. But Pluto is also the planet that's the furthest away from the sun in this solar system. There are some. I think they maybe discovered another planet further away, but Pluto has had that position for quite some time. And well, first of all, sometimes I call it the solar system, and sometimes I call it the star system. And what is the difference? Maybe you're wondering. Like a star system is what all the stars have. We call it the solar system because our star, the sun, also have like a name. We call it Sol. SOL. That's like a name for it. Sun is not really like SUN is not really a name. It's still a designation. If you were in another star system on a planet and you looked up at the star, you would say that this is the sun in this star system. But our sun is called Sol, which is why you have this name solar system. And what is in this solar system? Well, first you have this little planet called Mercury, and it's very close to the sun. And it's pretty hot there, it's pretty barren as well. I don't think there's actually much there except rock. And the next one is Venus. Yeah, Venus. And Venus is like a big boiling pot of gases and plasma and molten lava, and it's just like hell. You wouldn't be able to survive for any number of seconds, and you would melt away or be vaporized. You'd be you'd be destroyed by the acid storms. You would be eradicated on Venus. So don't go there. But you see, we have two planets before we get to Earth. And Earth has just the right distance from the sun And there's 149 million kilometers to the sun, which means it takes light approximately 8 minutes to travel there. And then what comes next? Well, next up is Mars. We Mars is they say there was once life there. There's a lot of weird things going on Mars. There's this there's this face, like a mountain range on Mars that looks like a face, and the movie Mission to Mars explored that theme. They say there's a lot of water on Mars that's underground, and there was once an atmosphere, and it looks like there was rivers and stuff, and they found microorganisms, and so yeah, in any case, Mars is primed. It's primed for anything. It's like it's ready for anything, terraforming or certainly settlements to some capacity. So Mars is a mystery. Mars is the next step. And next up is Jupiter. Like Jupiter is the giant, and the Earth can be inside Jupiter some crazy number of times. Maybe I'll look that up sometimes, but Jupiter is really big. And Jupiter it doesn't really have like a surface. It has like a gaseous surface, as whirling in some some kind of giant superstorm. There's an eye in Jupiter, like a black spot, and there's been crazy movies made about Jupiter, but Jupiter did one thing. It actually saved us at one point. We were being a couple of rogue asteroids just felt like they wanted to storm through our solar system and hit Earth, but Jupiter had such a gravitational pull that it actually stopped them. It pulled these asteroids to Jupiter instead of to Earth, and we saw this. We filmed these collisions, and you can look them up if you want to see. So you can actually liken Jupiter to some kind of giant garbage bin, or a vacuum cleaner, or some kind of magnet in our solar system, because it's taking care of us. It's like a bodyguard for us. And next up is Saturn. We're not gonna go into all the moons of all the planets, because I think Jupiter and Saturn has some kind of number of moons, but that's too specific right now. And but Saturn has this the rings around Saturn has this disc form set of rings, and there are so many theories about Saturn and why it's emitting this weird sound. I've been talking about that sounds Saturn emits. You really need to go and hear that sound because it's so frustrating. It sounds so devious and evil, and it's not monotonous. It's not like it doesn't sound like a natural phenomenon. It sounds like a message or some kind of controlling voice or something, almost like a broadcast. And Saturn have been depicted so many places in so many logos that we use in our daily lives, like Nike. Yeah, just look at the Nike symbol. It's a simplification of the rings around Saturn. Like NASA has it. There's a lot of symbols with Saturn and Saturday and satyrs and stuff. It's really in the center of mysticism and mythology and all kinds of weird rituals and I would really like to stand on a bridge on a starship and just say to Commander Data, please do a level 1 scan of this planet because something is really messed up right here. Like, how can these rings be like perfectly? There's two-dimensional almost, and they have like it looks like an LP, long play record, but it has these different colors, and the further away from Saturn you get, and many people say that it's a transmitting system, or they're not natural. It wouldn't be possible for that to exist. But anyway, it's very interesting. You should definitely check that out. Saturn, the devious planet. And next up is Uranus. Yes, Uranus is next. That is the classic joke about Uranus. You have the uranium from that name. Uranus. I don't really remember much about that planet. After that, you get Neptune, and that's is Neptune was it's the same name as like a lot of mythological god, water gods and water. At the bottom of the ocean where Poseidon sits, Neptune, the king of the sea. But after Neptune, you got Pluto, and so that's the lineup of the planets. And it's kind of interesting because the world was supposed to end the 21st of December last year, 2012. And why was that? That was because the Mayan calendar ended. And why did it end? It ended because it was the shift to a new age. And they just hadn't made something further than that. They made it thousands of years ago, and that was as far as they got, because at that time, at that day, all the planets in the solar system aligned. They aligned, and that has an impact. There's been tons of theories and movies about it, and and scientific discussions about what that could do. But the world didn't end. No, the world didn't end. So we're still here, ready to go, surviving, thriving. Well, but why this lineup? It's because, Pluto. The distance to Pluto is 7.5 billion kilometers. And what can we use that for? Well, you can probably imagine, like, how far that is. You can almost taste it, like how that distance. You can see the planets. You've seen the solar system in countless movies and in different scientific documentaries and stuff. So kind of like where Pluto is. Yeah. So one light year. If we're tying it back together, like one light year is 630 return trips to Pluto. You know. So light in 1 year, light travels back and forth to Pluto 630 times. You see, and this really ties into the big one, because the big one is the edge of space. The edge of space, and the edge of space is as far away as 9,000 billion return trips to Pluto. See, that's almost, you can almost taste it, right? 9,000 billion return trips to Pluto. 9,000 billion return trips to Pluto. And now you're starting to like almost touch, that faraway curtain of the edge of space, and that seems so weird and far away. And you should really be careful with these gigantic numbers. Like, the president of the United States came out like last year and said, we should we need to invest in schools, and of course it's a giant hoax. You should never believe anything that come out of his mouth. but he said we need to invest in schools. We're gonna make a foundation and invest $2 billion every year in schools. And you think, oh, 2 billion. He really wants to do something for the kids, right? Fucking bullshit. There's nothing, you know. And they trick you with these numbers, because at the same time they use 1.5 trillion for war, you know, for the military budget. But your mind, you're not used to dealing with billions and trillions. So you say, oh, 2 billion for school, and 2 trillions for war. What exactly? 2 trillion is not that much. It's just two, and then two, and then you see they trick you with those. When the numbers get so big, it's hard to handle, and you kind of shut down. And it doesn't make sense to us. But essentially it means that they spend 1,000 times more money on war than they do on education. And does that like just doesn't it just say everything, you know? 1,000 times more on war than education. Imagine a world with no hunger and no greed, and all the little kids know how to read. That was Roddenberry's famous words, and when is that gonna come true? Not when we spend 1,000 times more on war than we do on education. That's for certain. So the man is a demon, you know. The president of the United States right now is a demon. He's also a puppet. No doubt about it. He's not the man in charge. You know, he's just a front figure, and he's the most well-spoken front figure ever chosen by them. He's right on the money, you know, with the color of his skin and in his rhetorical abilities. So it's beautifully done, but he's still a demon, and everything that comes out of him is a lie. He should never have had the Nobel Prize. He should be executed, assassinated, or he should actually get he should get one of every vaccine he's ever invented, and then he should sit down and have a great meal with all the genetically modified food that Monsanto has invented, and then he should wash that down with a big old glass of fluorinated water, and then we can see what happens. I would like to see what happens to a human being when you get something like that in your body. It's also my belief that he's not actually a human being, but you know, that's different discussions. You know, I like to leave cliffhangers here, and I'll get back to that one. But I wanted to make another disclaimer, you know, about iron. Everything is turning to iron. And you know, all the atoms trying to either collide and grow bigger, or rip themselves apart and become smaller. And we call those two processes, you probably heard of that. We call them fusion and fission. Fusion is when two atoms collide or are squeezed together by something, usually gravity or magnetism, speed. That's what they do in CERN, in that huge laboratory in CERN. That's what they do there. They have a giant ring underground, and they speed up atoms to a crazy velocity, and then they collide them together and see what happens. And they created new atoms, and they also created like antimatter and stuff. Some were worried at one point that they were gonna create a black hole right in the middle of Switzerland. That would start sucking material into it. And swallow the entire Earth and solar system. It didn't happen, or hasn't happened yet. I guess they have all of eternity to pull that one off. But iron has 26 protons in the core, and also 26 neutrons and 26 electrons whirling around it. And you should really find your periodic table, or look it up, or just type it in and see it. The periodic table. Most people, some of my friends, or they've never seen it. Like the periodic table is like the menu of the universe, and just look at it, and where's McDonald's, on the periodic table? It's not there. Not even Burger King, is there on the periodic table. And how can that be? You got well, what do you got there? You get like uranium, the stuff they use in nuclear power plants. And what do you have? You have lead. The stuff that Superman cannot see through. You have gold on the periodic table, and you have oxygen, hydrogen, carbon, fluoride, chloride, and natrium. All the building blocks. But when you talk about classic elements like water and fire and earth and air, where are those? Those are not on the periodic table. You see, they are from a time where humans perceived their surrounding in a different way. Water is kind of like on there. It's H2O, and fire is what happens when carbon reacts with oxygen. You can burn wood, and what's in wood? Well, there's a lot of carbon in wood. So you just have to have heat, and you can ignite the fire in many ways, but it's not an atom in its own right. It's a chemical reaction, between carbon and oxygen, and then you get CO2, right? And CO2 is not a poison. Like Al Gore is saying that, oh God, you have to pay CO2 taxes, and everybody have to, like, you're a bad human. Oh, CO2, how much CO2 are you creating? Like, calm down. The trees and plants, they need CO2 to grow. That's the beauty of the system. It's photosynthesis. And what happens is that in the leaves of the plants, they take the CO2 out of the air, and they use the heat, the energy from the sun, that hits the plant, the sunlight, and they split CO2, and the plant keeps the carbon and releases the O2 again, so we can breathe it. And then you can hear me breathing right now, right? I'm breathing in oxygen and I'm breathing out CO2 because I need the oxygen. And what happens in my body is that is the same as fire. In every single cell in my body, there's something called a mitochondria, and it is a little furnace. And that is where the food that you eat is being distributed to every cell in your body. The carbon in the food that you eat, plants are made of carbon, and you eat it, and it goes through your bowels and into your blood and into your cells, and in your cells it goes into the mitochondria, and in the mitochondria it's being combined with the oxygen that you breathe. Every time you breathe, every couple of seconds you take in oxygen. It's being transported to your cells, and in the mitochondria they're being combined, just like fire. What comes out of that? Well, you get CO2 out of that, and energy. Right? You need energy to move around, to think, to sustain your being, And then the CO2 is carried in the blood to your lungs again, and there it's being released, and when you breathe out, the CO2 goes out into the world again, and then the plants get it and transform it to O2 again, and you see how the system works. But the goddamn government wants you to believe that, it's a poison. Yes, we're suffocating ourselves, and it's wrong, and bullshit. What's wrong is all the dangerous chemicals that they're putting out there, and all the particles from gasoline, like all the oxidants. What is this antioxidant talk we got going on? it's in this reaction in the cell, when it burns, it's not a pure it's not a pure burn in there, depending on what you put in your body. If you eat all the nasty shit, all the greasy stuff, all the additives, if you just pick up something from the supermarket and look at the description of all the different nasty evil pieces of disgusting additives they put in there, that's what you eat, and that's what your cells have to burn, they have to make sense of that. And you're putting this garbage into your small innocent cells, and the furnace in there, the mitochondria in there says, oh my god, I have to burn this French fry from fucking McDonald's. And what happens is that it does it does burn it, but it spews out these oxidants, like these it's basically oxygen likes to travel in pairs. That's why it's called O2. That's what's in the air. It's like CO2, carbon and double oxygen. But an oxidant is an oxygen atom that's traveling alone, and it's very reactive. It wants to play with other atoms, and it when it in the cell, when it hits the DNA string. There's many different things in your cells, but one of them is a DNA string, and that's your genetic code. And when free radicals, as we call them, these particles that comes out of the combustion inside your mitochondria, when they hit the DNA molecules, they break them down, or they transform them, mutate them, and turn them into cancer cells. Just defiles your poor DNA molecules, right? And stuff like the particles from diesel fuel, and all the pollution that you eat and breathe and all that, it does the same thing, it corrupts your genetic code in the most horrible way. And it's all the Big Bang's fault, because we don't need to do all this horrible stuff we do to planet Earth and we do to other people. It's not necessary, but we do it to create a profit, right? Like McDonald's, they want you to go in there and ingest their poison so that they can make a profit, right? And serve the banks that own them. That was a bit of a chemistry session there. So we got water, and we got fire, and earth. Earth is what they was an element. We still, like in all the games and the mythology and in our minds, we still think of the four elements: earth, wind, water, and fire. And earth is a compilation of a lot of different stuff. If you have like a good portion of, if you go out into the garden and you put your hands in the soil, that's the closest thing we really come to earth. And how is that made? Well, maybe you have like a pile where you put all your plant matter and um, compost, like a compost pile. You see, and all the plant matter breaks down and becomes earth or soil, and that's through. Well, there's a lot of microorganism that breaks down the plant matter and excrete kind of a brown a substance that is rich in minerals and it's got phosphates and different compounds that the plants need to grow, right? Like fertilizer. So Earth is like a giant mixer pot of different components. There's a lot of carbon in there, old plant matter. It really depends where you stick your hand in the ground, right? And then you got air. And air is not on the periodic table because it consists of, well, quite a few things. There's 70% in nitrogen. And that's like, yeah, that's like the most non-reactive chemical compound you can get your hands on. It's basically neutral. It doesn't really want to react with anything. Of course, you have O2 in there. In our atmosphere, you have carbon dioxide. It's CO2. That is only like below 1%, like 0.7% or something. I think it's 0.4% is carbon dioxide. And you got many more times oxygen than that, and it's actually been dropping, the last couple of years. It's not as high as all the globalists want you to think, to pay the goddamn CO2 taxes. Not as high at all. It's been dropping, you know. And they have these many examples of when the CO2 levels rise in a certain area, all the plant life just springs to life. Plants grow wild because they need this, right? It's like the breath of life to them. It's not a poison, guys. It's not a poison. And in the air, you also have a lot of other gases that are non-reactive. We call them noble gases. there's like stable atoms that they're at the end, the right edge of the periodic table. You have the noble gases, also very hard to react with. So the two reactive compounds in air is O2 and CO2, and that is what we call air. So you see, and iron is right there in the middle. Everything wants to become iron. Imagine that, you know. The entire universe filled with iron, nothing but iron. That would suck, wouldn't it? Like, how are you supposed to make love if everything around you is iron? I hope something beautiful and passionate happens before that, because who the fuck wants to fly around in a universe where everything is iron? I'm thinking about, you know, this book read once. My father gave me this book about the theory of relativity, and imagine, you know, we have this photon that's at the edge of space. This little photon that's it's 9,000 billion return trips to Pluto away from us right now. And imagine a Ferengi sitting on this photon, you know. If a Ferengi had somehow hitched a ride on this photon at the edge of space, and he's he's sitting there with his big ears and his little pointy teeth and his intense eyes, and he's just ready to go, right? He's 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 just he's wondering, well, what's just a little bit further ahead, like what is out there, and he's of course thinking that his gold-plated latinum is waiting out there. That's why he hitched a ride, you know. He wants the gold. He wants the treasure chest. And in his hand is a phaser, you know, a future weapon, and he's about to shoot, because he's so frustrated, and he's been sitting on this photon for 13.7 billion years, and he's getting anxious, you know, frustrated even. And he sees the golden arches in the distance, you know, and he just he opens fire with his phaser at. But what comes out? You know, in Star Trek, a phaser is like it shoots laser, and laser is basically just light. Concentrated light. But if he's traveling at the speed of light, and he pushes the button on the phaser gun. What comes out of it? You know? Because what comes out of it cannot travel faster than he's already traveling. So what happens? Does it stay in his phaser, or it cannot suddenly travel double as fast? It's just nothing happened. His weapon misfires, and you know, McDonald's is still out there, beyond the edge of space, and we really need to shoot that down. But you know, the Ferengi, he can't fire that weapon, you know, because he's already moving at the speed of light. So you see the predicament we're in here. Yeah, but fortunately, there's a lot of good stuff happening, you know, inside of known space. You know, you don't really have to go all the way out there to experience all the delicious things that life have to offer, and so we're on this planet, right? On this little blue planet, and traveling through space, being controlled by an evil elite, just trying to connect with the universe. And we are. So I'm gonna close this captain's log, guys, and I hope you learned something, 'cause I did. And until next time, this is Mike saying good luck.